Good evening, everyone. My name is Rashumba Llewellyn, and I'd like to welcome you back to another Tech Talk in our series sponsored by Bracklet. Today, we have the pleasure of welcoming Tucker Olson to give us a brief talk about real-time communication. So without further ado, I'd like to pass it over to you, Tucker.
Thanks, Rashimba, and thank you, Bracklet, for sponsoring this talk. Um, Good afternoon, everyone. Before I begin, let's take a step back, zoom out, if you will. In this Zoom call, I'm speaking, and within milliseconds, you're hearing my voice and seeing my video. When I raise my hand, you see it almost instantly. That experience of being connected live, even though we're not in the same room, is powered by real-time communication. Without it, the Zoom call wouldn't be possible. Instead, you'd see my words arrive minutes late, or you'd have to refresh your screen constantly to catch up. So the very fact that we're able to have this conversation today is a living example of real-time communication. This is what allows us to see messages instantly, hear someone's voice without delay, and collaborate live as if distance doesn't matter. Without it, our digital world would feel much slower and disconnected. Today's agenda, we're going to guide you through what real-time communication is, how the underlying technology works, and we'll dive deep into the three main technologies that make it possible: WebSocket, Socket.io, and WebRTC. Hopefully, by the end, you'll have a clear picture of how these tools shape our digital interactions. What is RTC? At its core, real-time communication means transmitting data instantly with little to no delay between two or more parties. Unlike traditional communication methods, like sending an email where messages sit on a server until it's pulled down, real-time communication creates a direct, ongoing channel. This matters because human connection thrives on immediacy. A video call isn't valuable if each word lags by 3 seconds. Video games would have no online multiplayer component, and who wants to live in a world where you can't lose to a 10-year-old kid from Canada talking trash about you and getting a little too personal? Not me. Real-time communication solves this problem by making the digital world synchronous or live. Technically, real-time communication is made possible through persistent connections between a client, like your browser, and a server. Instead of constantly asking, "Do you have anything new for me?" which is what older technologies like polling did, real-time systems keep a two-way street open. This way, either side can send information the moment it's available. Think of it like a phone call instead of writing letters back and forth. The phone line stays open until you hang up, and anyone on the call can speak at any time. Let's go over the three main technologies that power most of real-time experiences we use every day: WebSocket, Socket.io, and WebRTC. WebSocket is the foundation. It creates a persistent two-way connection between a client, like your browser, and a server. Once that connection is open, data can flow instantly in both directions. This is great for things like collaborative dashboards or multiplayer games where speed really matters. Just ask that 10-year-old kid whose speed is always somehow faster than mine. Next, we have Socket.io. Think of it as a developer-friendly tool built around WebSocket. It gives you reliability and extra features like automatic reconnection if the connection drops, or falling back to other methods if WebSocket isn't available. That's why it's so common in real-time chat apps and collaborative tools where you want smooth communication without worrying about the technical details. And then there's WebRTC. This is a bit different because it's designed for direct peer-to-peer connections between devices. It's the backbone of video and voice calls, like what we're using in Zoom right now. And it even supports sharing files directly from one person to another without going through a central server. So in short, WebSocket provides a raw live connection. Socket.io makes a more reliable and easier to use, makes it more reliable. And WebRTC makes real-time video, audio, and peer-to-peer sharing possible. First off, for WebSocket, just to go a little deeper, um, the WebSocket is the foundation of much of what real-time communication on the web is. How it works is it begins with an HTTP request, but then the communication upgrades into a WebSocket, creating a single persistent channel between client and server. From that point on, messages can flow both ways instantly. Benefits of this is its low latency. Messages are delivered with almost no delay. It's bidirectional. Both client and server can send data freely. It's lightweight, less overhead compared to constantly polling the server. Some drawbacks, though, is its complexity. Managing state and scaling WebSocket servers can be complicated and tricky. Not ideal for broadcasting to many users without additional infrastructure and limited built-in features. It's just a protocol, not a full toolkit. So you have to handle things like reconnection and fallbacks yourself. Next is Socket.io, which builds on WebSocket but adds many developer-friendly features. So how it works is WebSocket.io abstracts away the details of WebSocket and other protocols. It automatically falls back to alternatives like long polling if WebSockets aren't supported, ensuring compatibility across browsers. It also adds built-in support for rooms, namespaces, and reconnection handling. After the initial connection is made, audio, video streams, and data channels can be shared peer-to-peer. The benefits of this is it establishes easier development. It provides events and utilities right out of the box. It's reliable. It handles connection failures and retries automatically. And then it's also flexible, lets you organize users into rooms or channels for broadcasting. Some drawbacks, though, is there is more overhead than pure WebSockets, which can mean slightly higher latency. It does require also using the Socket.io library on both client and server, which can reduce how other systems work with each other. So in short, Socket.io trades some performance for convenience and reliability. Lastly is WebRTC, which stands for real-time communication. Unlike WebSocket and Socket.io, which mainly connect client to server, WebRTC is designed for peer-to-peer connection, such as live video and voice calls. How it works is first two devices, let's say my computer and that 10-year-old kid's computer, need to find each other and agree on how to connect. That initial coordination is handled by something called signaling, which usually goes through a normal server. Once signaling is done, WebRTC tries to create a direct connection between two peers or enemies. To do this, it often uses stun servers, which help each device figure out its public IP address and how it looks to the outside world. You should definitely not use this to expose the IP address of your new Canadian enemy. Now, if direct connection can't be established because of your firewalls or strict networks, WebRTC falls back to turn servers, which act like middleman relays to each other. This guarantees the connection works, but with a little extra delay since the data flows through a relay instead of directly. However, once the connection is established, the peers can send audio, video, or any other arbitrary data directly to each other, encrypted end to end. The benefits of this is peer-to-peer, reduces server load and latency. It does have native support in modern browsers, so no plugins are required. It is ideal for video conferencing, file sharing, and voice chat. More importantly, it can be used to DDoS a 10-year-old Canadian kid. Uh, Drawbacks, though, it is complex. Setting up signaling, NAT traversal, and security can be challenging. It doesn't scale well for large groups without a server to relay streams. Limited control compared to low-level technologies as well. In conclusion, today we started with everyday examples like messaging apps, video calls, and online games to ground ourselves in why real-time communication matters. Then we explored some of the different technologies that power it. We looked at WebSocket, which is the protocol that creates fast, lightweight channels between client and server. Socket.io, the library that adds reliability, fallback, and ease of use. WebRTC, which adds the peer-to-peer technology that makes video calls and direct data sharing possible. Each has its strengths, its drawbacks, and its best fit scenarios. So the next time you talk trash on someone online, you might want to consider behind that RTC connection could be a software engineer that kicks you off the server for the rest of the night. Thank you all for your time today. This is my works cited page. And once again, big thanks to Bracklet for sponsoring, and I'll pass it back to you, Rashenda.
Thank you so much, Tucker, for that informative talk. And thank you to everyone for coming out tonight. We'll see you at the next one.